All right, second time me trying to start this. We are going to be working today with rational functions, okay? And in particular, graphing them. We've worked with them before. We've worked with functions that were fractions with x's on top, x's on bottom, how to simplify them, how to add, subtract, multiply, divide them. Today we're going to be talking about graphing them, and it is a complicated process. It is different from our vertex form graphs. It is not A, B's, H's, and K's. And so we're going to want a little study guide. If you're following along in the video, you might want to go ahead and make a little study guide. Take a piece of paper, fold it so that it has two flaps like this, kind of use a pencil and make it so you've got 1, 2, 3 different sections on each flap, and then open up the book so that it looks like this, and then draw these. So you've basically got 6 sections. 1, 2, 3, 4, 5, 6. You got 1, 2, 3, 4, 5, 6 on the outside. And that way, if you need to find, for example, blah, 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 you can open it up, and right inside here, you'll see what you need, okay? It's going to be a really easy way to solve these questions on the test, because the test is going to say, tell me about where the domain is. You're going to open up the domain flap, and you're going to have the answer right there looking at you. So pause the video, make one of these. We're going to go in, and I'm not going to give you enough time to do it if you don't pause the video. I'll just give you that right now. So moving on. Hopefully you've paused the video and you've got one of those booklets made. Rational functions are a function of the form, and they want to make this really complicated here. Here's the way I like to put it, okay? We're going to have a fraction. We're going to have x on top. We're going to have x on bottom, okay? Good morning. So a rational function, I mean, it's as simple as that. You're going to have x's on top and x's on bottom, and you got to know how to handle it. We have handled it in the past, okay? We've done questions, just to kind of throw one up and remind you one really quickly, right? We might have seen something that looked like x squared minus 9 over x squared minus 5x plus 6, right? Something like this. We would have to first factor this. And so we would factor it, and we would get x minus 3, x plus 3. On the bottom, we would have x minus 3, x minus 2. And then we would kind of play the fruit ninja thing. We'd slice these off, right? The x minus 3 and the x minus 3 would cancel out. And our final answer would be this, x plus 3 over x minus 2. Okay, we've done that before to this year, and we're working on the exact same type of questions, except for how do they look on a graph? Okay, there are still rational functions. They still look like this. They're still of this form. We're still going to need to know how to do this a little bit. Okay, so make sure that you're comfortable and you remember the fact that we cannot cross these x squareds out. Even though they both have x squared on top and bottom, that this minus has locked these two things together, that these are locked together because of that minus, right? That all three of these things are locked together because of these pluses and minuses. So that's all stuff we've done in the past. Hold on to that stuff. That's what a rational function is. Now you can see steps to graph 1, 2, 3, 4, which is very complicated. 5. There's a whole bunch of stuff going on here. Okay, and that's why we need our little study guide to make sure we're straight. We've got this thing here. What is a whole? We'll come back and talk about it. Let's just go and jump into number 1, and let's just see if we can start to talk about this, okay? So this is a rational function. We got x's on top. We got x's on bottom. Can we simplify this at all in any way, okay? Can we reduce the top? Can we reduce the bottom? Can we perhaps factor the top or factor the bottom? Could we cross out the top and the bottom? Is there anything we can do with this function? No, there's nothing we can do, okay? Even though they both have x's, even though they both have 4s, these are two different things. We cannot cross them out, okay? And so this is it. This is as simple as it gets. It's time for us to graph it and see how it looks. So let's do that. I'm just going to go straight into Desmos and try this out. So going over to Desmos, I'm going to go ahead and make a fraction. I've got x minus 4 on top. I've got x plus 4 on bottom. Don't need the all caps. Make sure that I got it right. It is a minus 4 on top, plus 4 on bottom. Perfect. And so here's my function. Okay, I'm going to go back home so I can look at this. Here's my function. We have not really ever seen a function that looks like this. Okay? In a way, it should kind of look like an exponential function here, and it should kind of look like a log function here, right? So we've got some pieces that look familiar, but we've never seen a graph like this that's got two separate pieces. Okay, if I zoom out, one thing that's different from an exponential graph and from a log graph is that this function is bound by an asymptote, okay? Normally our exponential functions would keep going to the right and would keep going to the right and would keep going to the right, but this function does not, okay? It is bound by an asymptote. As I trace this, you can see, looking at my x value here, negative 4.1, negative 4, negative 4, negative 4, negative 4, negative 4, and it is going to be basically stuck at negative 4 the whole way, okay? What's going on here with these functions, I'll go back home, is that we are going to have two asymptotes, okay? I told you with log functions and exponential functions, don't be the student that puts two asymptotes on those functions. But when it comes to rational functions, we're going to have two asymptotes a lot of the times. Now, perhaps we might even see one today where we have three asymptotes, right? Which sounds crazy and will look a little crazy too. So this function is going to have multiple asymptotes. It's going to have a horizontal asymptote and it's going to have a vertical asymptote. Okay, so if I put in a little, maybe a y equals a and maybe an x equals b, and then I need to add these sliders because Desmos doesn't really know what's going on here, right? So if I put a equals 2 and maybe b equals 2, I've made this a lot complicated, but now you can see that I've got these two asymptotes, okay? And I'm going to make them both red so they look like asymptotes. And I can also, in Desmos, make them dotted lines, which is how we represent asymptotes a lot of times. And so as I move this asymptote, you can kind of get the idea for where it should be, right? Right about in this region is where it looks like it should go, right? Because it should not touch either one of these blue pieces, okay? And my B graph, my B asymptote, should be right about in this region, right? Because it should never intersect the blue graph or the blue graph, right? And so looking at these two, looks pretty solid, right? I don't really see any point that my red graph and my blue graph intersect, which means that I think I've kind of nailed it on the head here, okay, as to where my asymptote should be. And hopefully these asymptotes in place kind of help you out, okay? A lot of times the way that students think about these is these asymptotes kind of make like a window pane, and then these curves are kind of like the snow that gets in the window pane, you know, in like a cartoon picture where you have like the snow just nestled in all the windows, right? So let's see how we actually find these numbers. So I've settled on the number of 1 for my y. So that's y equals 1. And then negative 4 for my b. So that's x equals negative 4. So my horizontal asymptote at a positive 1 value. My x-intercept at a negative 4 value. So let's go back here. The first thing that we're going to talk about is our asymptotes, okay? And so what I would recommend is if you made some of these tabs extra big, you probably want to put your asymptotes there on those extra big ones. But for me, all mine are relatively the same. So on the outside, I'm going to go ahead and put horizontal asymptote. Oh. I would recommend, yeah, if you have an extra big section, I would put these asymptotes there. I mean, you're going to need one that says horizontal, one that says vertical, but you're going to open it up. So write it like a book. You know what I'm saying? Just like I've written mine. Obviously, yours will just be on the middle flat. And so I know you guys are all smart students. But just to explain what's going on here, right? The horizontal flap is on top of this section, right? So we're going to write what a horizontal asymptote is in this section. And then, the vertical asymptote is going to be on the flap of this section. So we're going to do this kind of thing. You don't need to highlight this necessarily. This will be dead obvious when you're doing it on your own piece of paper, but I just want to be clear the way my diagram is written. I wish it was cool enough that I could set it up better for you guys, but let's start with the vertical asymptote, okay? I've kind of described to you guys, that asymptotes, I like to think of them as kind of like fiery pits of death, right? Like really spooky lines that the graph is just so scared of and the graph can't touch. Even though it gets closer and closer and closer, it'll never actually touch the asymptote, okay? Now, when it comes to vertical asymptote, so I'm over here in the vertical asymptote, right? Maybe I'll put a little vertical asymptote reminder there. Our vertical asymptote is even more scary than a horizontal asymptote, okay? Which seems kind of arbitrary to you guys, and they're both asymptotes. But a vertical asymptote comes from whenever your bottom is equal to 0, okay? If you've divided by 0, that is a very bad thing, and that is going to create an asymptote, okay? A place in which you cannot go because you cannot divide by 0, okay? That vertical asymptote is kind of like the elephant graveyard, right? If you're talking about Lion King, like you can be anywhere, but do not let the bottom divide by 0, okay? Now, obviously, really that's all we need to say. So what I would do, if you've still got some room here, which I think you do, is to go ahead and maybe draw something like this. And maybe we'll just make a little equation here, right? Like x over x minus 5, something like that. Okay, obviously you have like a fold right here, if you get me. Now we know that this graph would have a vertical and a horizontal asymptote, but we're working on vertical asymptotes, right? So we would have a vertical asymptote right here at x equals 5. And that's because that is where the bottom is equal to 0, right? 5 is a number we cannot go. Because if we put a 5 in the bottom, we get 5 minus 5, and the universe is sucked into a black hole, right? We are not allowed at all to divide by 5 in this example. Or sorry, to plug in a 5, which would be dividing by 0. So one thing you can do is you can just, if we're talking about bottom equals 0, you can just take the bottom. You can just put x minus 5 equals 0, and then you can just say, okay, x equals 5. Now, remember that this x equals 5 is a bad thing. X should not equal 5. And that's why it makes a little asymptote. So at the end of the day, the vertical asymptote is not that complicated, right? Wherever your bottom is equal to 0 is bad. Wherever your bottom is equal to 0, that would make a vertical asymptote. So if we go back here, and I'll be bouncing back and forth, so hopefully you got time to copy that. But when we go back here, and we're going to try to find our vertical asymptote, I'm going to write some little notes here, right, just to help us practice here. Our vertical asymptote is our bottom equal to 0, and that vertical asymptote would be x plus 4 equal to 0. Because that is the bottom equal to 0. We're going to go ahead and solve that. And so my vertical asymptote is x equals negative 4. This is my vertical asymptote. So I'll go ahead and get my ruler out because I'm not very good at these straight up and down lines. At negative 4, we're going to have an asymptote. We can go ahead and put that on our graph, okay? Sometimes you can use a dotted line or a squiggly line if you can't see it very well. But that's all there is to it, right? We found our vertical asymptote. We we can go back over here to where it says vertical asymptote. We can write that down, x equals -4. And remember, checking back to Desmos, that's exactly what, I mean, I kind of knew what I was doing, but that's exactly what I figured out beforehand, right? This x equals -4 is this vertical line that is kind of between the two blue curves, right? That is not touching them either way, that they're both scared of, right? This one on top is scared of the asymptote, and this one on the bottom is also scared of the asymptote, okay? So that's the vertical asymptote. That's it. And in fact, the vertical asymptote is the place that I always like to do first because it is the scariest thing for the graph. It's also really easy for us to find in general. Now, the horizontal asymptote is probably the strangest, maybe the hardest one for us to find, okay? And so if you look at these notes on the front of your paper here, right, a lot of this is there for you, okay? For one, number 3 says, find the vertical asymptote by setting the denominator equal to 0. Okay, that's perfect, right? That is literally exactly what we just did. Nice. We're done with that. That seems good. Horizontal asymptote using the following rules below. Now, this is a totally legitimate way to write it. Degree of P, degree of Q, degree of P, degree of Q. Okay, it's a legitimate way of doing it, but it is not the easiest way of doing it. So here's what we're going to do. We're going to go up here. We're going to go into our box. And we're going to start with 2 bits of vocab. Okay, so what I would do is on your little open flap of your horizontal asymptote, let's do a little bit of vocab. There's 2 things that we need to remind ourselves of. I think we've seen these before. One of them is the vocab word degree. And again, we're going to try to fit this on our flap, if you will. So the word degree, if you've seen this in Algebra 2, great. If you've forgotten it, that's fine. Degree is, let me zoom in a bit so I can write neater for you guys. The degree is simply the highest exponent. And I said I'd zoom in so the writing would get better, and it didn't really get that much better. So let me give it one more shot. The highest exponent. So we need to know that. We need to know what the degree is. The degree is the highest exponent. And it's not that hard to find, right? Going down to our question here, right? The highest exponent is a 1 on top, is a 1 on bottom. If we look down here, it's a 1 and a 1. If we look down here, the degree would be a 2. And the degree would be a 1, right? So if you don't see an exponent, the degree is 1. Down here would be 1 on top, 2 on bottom. Okay, really simply, the degree is just looking at the exponents, okay? And the other one that we need to figure out, unfortunately, is a long word itself, okay? And that is the leading coefficient. Again, possible that you've heard of these before, and you've already kind of understood what these are. The leading coefficient. It's kind of like an O. The leading coefficient. Now, the leading coefficient is basically the number, because coefficient means number, is basically the number in the lead, the number that is out front. Okay? So the leading coefficient would be simply the number in front of not the leading coefficient. The number in front of the highest exponent. So let's be very clear. This is a really easy two pieces of vocab, right? If I've got the function 5x cubed plus 3x plus 1, if I've got the function negative x squared plus 2x plus 5, if I've got the function negative 7x to the 6 plus 3x cubed plus 2. If I've got these functions, the degree is 3, the degree is 2, the degree is 6. It's literally just the highest exponent. The leading coefficient would be 5. That would be like a negative 1, of course, because it's just a negative sign, so a negative 1, and then that would be like a negative 7. Okay, so your degrees are simply the exponents. Your leading coefficients are simply the numbers out front. So it's a really easy, it might sound kind of crazy when you first hear it, but it's a really easy kind of concept to work through. I'm going to erase this, but shouldn't be too tricky. Now, again, the rest of these flaps are going to be much, much, much easier than this one. This is definitely the hardest one. Now, inside here, we're going to need to write at the top, compare degree, and then in here, we want to make a little chart. Again, I know this seems crazy, but this little study guide will solve the questions for you, right? It'll save you so much heartache. So in here, we want to make something that looks a lot like our flip book, honestly. The thing about horizontal asymptotes is that we have a couple different possibilities, right? Our vertical asymptote every single time is going to be bottom equal to 0, and that is a piece of cake. Our horizontal asymptote is not as straightforward, okay? And there's actually 3 different case scenarios that we have, okay? I'll even do this one in orange so that we remember it. We just defined it over there. So, our 3 different possibilities are, once we compare the degrees, okay, that our bottom is bigger than our top, okay? And again, you might, if you've got a highlighter, which I recommend, you might want to highlight this part here. Because what we are comparing is the degrees. It has nothing to do with anything else besides the degrees. Now, if our bottom perhaps has a bigger degree than the top does, really simple. Horizontal asymptote, y equals 0. And so you can realize that the reason we're doing this study guide is that if you open up this study guide and the question says, what is the horizontal asymptote? You open it up, it says compare your degrees. If the bottom's bigger, y equals 0. That's your answer, okay? If your top is bigger, and this answer is even easier than that one, none. You're not even going to have a horizontal asymptote. And there's only one final way to write this here. If your top is the same as your bottom, or if your bottom is the same as the top, right? So now we just need kind of top is equal to your bottom. And if your top is equal to your bottom, this is the weirdest circumstance, okay? It would be y equals a fraction of LC divided by LC, okay? Any of you guys in class know what LC probably means? You've heard it within the last minute and a half, right? So the reason that we've got these 2 definitions over here, okay? Right, we need to look at the degrees and possibly use the leading coefficient. Obviously, we don't have room to write leading coefficient right here, so we're just going with LCs. If you need to make a little hint arrow, you're welcome to do that. If you need to maybe, a little light highlighter line perhaps, or, maybe it looks more like this so that it doesn't necessarily cross through everything that you've just made. But if you need to make a little reminder, that's fine. Yeah. So now we've talked about our two asymptote rules, okay? And the truth is, as much as this seems crazy, we can solve these asymptotes in like 30 seconds. We can do both of them, okay? Where is the bottom equal to 0? We're done. That's the vertical asymptote. Then comparing the degrees takes almost no time at all, okay? So again, let's do some little examples with horizontal asymptote, okay? If I've got a fraction and I've got x squared plus 2x plus 1, and then I've got x cubed minus 9, what would our horizontal asymptote be for this function? So first thing we need to do is compare the degrees. Look at the degrees. Which side, the top or the bottom, has a bigger degree? The top or the bottom? The bottom does, right? What we've got here is we've got a degree of 3, a degree of 2, and so the bottom is bigger. Okay, so we're going to go and now reference our chart. If your bottom is bigger, y equals 0. There you go. We're done. Y equals 0 is the whole horizontal asymptote. We don't have to think about it too much. Now, if we go down here, actually, it's quite a while down here, and we check out our question, and we're going to work on horizontal asymptote now. Our horizontal asymptote is where we compare degrees. And again, I'm writing this because it is a really, really good habit. And because when you go back to study or when you go back on your test and you get stuck, having this information here is going to make it very clear what you're doing, right? So what is the degree on the top? Just a 1, right? It's kind of like an invisible 1, but it's just a 1. What is the degree on the bottom? Also a 1. And now compare them. Which one's bigger? Well, Mr. Collier, duh, they're both the same, okay? So let's go back up here. What do we do if they're both the same? We make a fraction of the leading coefficient divided by the leading coefficient. Okay, coming all the way back here. If we make a fraction of the leading coefficient divided by the leading coefficient, okay, that would be a fraction of these two numbers. The numbers in front of the x and the numbers in front of the x. Now, there's not really any numbers there either, right? Technically, there's a 1 on top, and technically, there's a 1 on bottom. And so our fraction would be 1 divided by 1. And so our horizontal asymptote would be y equals 1, which is really, if you want to write it like this just for the sake of being specific, right? It's y equals 1 over 1, which we're just going to simplify to make 1. Okay? Cool. Let's throw that up on our graph here. Let's make sure that we fill in our horizontal asymptote over here as well. Y equals 1. Now, once we found this and we found our two asymptotes, we need to start to talk about some other stuff, okay? So, for example, X-Intercept is what is asked for in this question, okay? So, let's go back up here. And let's go to this bottom flap, and let's write Desmos. Okay. Now, the way I'm teaching you here is going to be, in accordance with the Virginia SOL, which means you're allowed to use Desmos. And I'll tell you right now, you might as well use Desmos because that thing is crazy. Okay, that thing is overpowered, if anything. Okay, Desmos will do a lot of this for you. Okay, Desmos cannot show you what the asymptotes are, which is why we needed to learn there what the asymptotes are, right? If you remember going back here to our function, we got the y equals 1 perfectly. That was comparing the degrees to get our horizontal asymptote. We got the x equals -4. But Desmos does not show you those, right? You can't just pull up the Desmos and look for the asymptotes. It's not that easy, okay? I was able to kind of be clever about it and place them where I thought that they would go, which you can do a little bit to get a good idea, but it's not going to tell you the exact thing. Now, Desmos will tell you other stuff, okay? Now, our graph is the blue graph, and so where do I touch the x-axis, okay? It'll figure this out for us, right? I know that there is a horizontal asymptote, and so this blue line is never going to get to the intercept, okay? And so the only time I'm going to have an x-intercept is right here. It's the only possible time. The reason is this one will never get over the asymptote, and this one is getting closer and closer to the asymptote. It's never going to break away from the asymptote. So I've only got one intercept. It would be at 4, 0. And so on the inside of your little flip book here, Desmos will solve for you x-intercepts. Desmos will solve for you y-intercepts. Let me see, we've got our little fold here. And Desmos will also show you the general shape. Now, if we wanted to solve for these, technically your x-intercept is top equals 0. If you wanted to find your x-intercept, you could set the top equal to 0. But just type it in Desmos. You know what I'm saying? Like, you don't need to worry about this. Just type it in Desmos, click on the dots. It's that simple, right? Y-intercept. Technically, this would be setting x equal to 0. And in the past, kids had to learn this, and they had to do this. Just type in Desmos. Right? Don't make it difficult on yourself. You don't need to memorize that the top equals 0 is for your x-intercept, or that the x equals 0 would be your y-intercept. Just type them in Desmos. Now, your general shape is either going to look like this, or it's going to look like this. I mean, this is a general idea. Obviously, you'll have some asymptotes in there. But you really just have these two options. Really, these are your only two options. You can never have a function that has two of them that are on top of each other, because that wouldn't pass the vertical line test, and that wouldn't be a function, okay? So, for example, you'll never see a function that is this blue line and also this blue line. That'll never happen, because that's not allowed. So it'll always be either bottom top or top bottom. Okay, we're not going to deal with a whole lot of stuff that would be, top top or bottom bottom. It's pretty much going to be one or the other. So we're in Desmos. We see that it's on the top side and then the bottom side. And so for our graph down here, we're going to graph a curvy line that needs to be near this line and needs to be near this line. I don't really care how it looks in between here. It needs to kind of get into the corner, but it doesn't need to go crazy into the corner, right? You really just get to kind of near the asymptote, right? It doesn't really need to be perfect, okay? Near the asymptote. Like, it's really not that big of a deal. Some kids like to do a really big curve here. As long as it looks like it is near the asymptote and near the asymptote, that is totally fine. I'll tell you what's not fine. That's not good. Okay? This is bad. You cannot have your graph escaping the asymptote. Okay? So make sure that you've entered and exited along the asymptote, and then just make a little curve and go from there. So I'll go with this one. That's good enough. Now on the bottom, again, it's the same general idea. We do have some information though, right? We did find out what our X-intercept was, okay? We did find out that our X-intercept was at 4. So if we want to be exact, we can put a little dot here. That should be our X-intercept. That should be where we cross. And so, you know, if we want to be exact about it, but it doesn't really have to be that serious. Let's go ahead and fill in a bit more of this information. Our X-intercept here we found out was 4, 0. We just used Desmos for that one. And now we get to these ones down at the bottom. Our whole, our domain, and our range. Okay, I'll tell you right now, the whole for this example is none. There's not always a whole. In fact, in real life, a whole would be a very rare thing. In math class, it's relatively rare. But you'll still see on a test maybe 2 questions about a whole. So we'll talk about that in a second. Now, domain and range. Let's go back up here. Let's put domain and range as our 2 kind of middle ones. Okay? And as you can see, we're almost done. Domain, range. And if you look at our general shapes, okay, our domain is where does our graph go to the right, and go to the left. And if you look at this function, it looks like it's going to the right, looks like it's going to the left. And so typically, when we're doing domain, it's like, oh, well, it goes right, it goes left, so it's all real numbers. But for this function, it is not in the middle, right? It's everywhere else, okay? The function is all over here. The function is all over here, but it is not at that vertical asymptote, okay? And so our domain is pretty simple, okay? Our domain is all real numbers because it goes left and it goes right. But, and sometimes we can even write but your X cannot be the vertical asymptote. Right? Your graph is literally everywhere except for the vertical asymptote. Okay? And it's the same thing with the range. Okay? Your range is all real numbers, but Y is not the horizontal asymptote. Okay? Because it's not the vertical asymptote again. The vertical asymptote is not affecting your range. It's the horizontal asymptote. Okay? And again, that's not that hard to do. If we go to our question here, these 2 answers that we've got for our vertical asymptote and horizontal asymptote, pretty much the same answers we're going to use for our domain and range. Now, unfortunately, I've done those backwards. It would be more like this and this. So, what is our domain and what is our range? Well, it's going to be all real numbers. It's going to be all real numbers. But we need a little disclaimer here. But For your domain, x cannot be -4. We've literally just taken the vertical asymptote and we've just put it right here. For our range, y cannot be 1. We've literally just taken the horizontal asymptote and we've put it right there. Let me go back to get rid of that circle. And so again, a lot like with exponentials and logs, they're a lot more repetitive than you'd think when you first start, right? We see the vertical asymptote, we see the domain. They're basically the same. With the horizontal asymptote, the range, basically the same. Whole, none. That was easy. X-intercept, Desmos. That was easy. If you think about rationals, it's 6 easy things to do. But that's a lot of easy things to do for one question, right? And so that you really want to hold on to that study guide. What I'm going to do now is skip ahead to a question like number 4 on your notes. A question like number 4 on the notes is, in my mind, like the perfect question when it comes to rationals, okay? You've got to do everything that you need to do in order to solve this. It's got one of everything. It's just like the perfect question. So let's work on this one, okay? One thing that you can do is you can just type it in Desmos as a decent start, okay? Let's go to Desmos. Let's go ahead and make a fraction. Let's do x squared. Nope, just x plus 5. X plus 5 on the bottom. I know that we've got x squared plus 9x plus 20. Let me double check that. X squared plus 9x plus 20. Okay, going back home. Yeah, looks like we'd expect. Okay, we got a vertical asymptote in there somewhere. We got a horizontal asymptote in there somewhere. We're going from low to high, which is totally fine. And you can probably kind of identify where that vertical asymptote is, where that horizontal asymptote is, right? It's not that hard to do. Now, I wouldn't recommend just going off your vision and just glancing here. So let's solve this out. Now, one thing that we did not have to do for the first question is you have to factor first, okay? We need to factor and break this down, which is no different than when we did rationals before. I like this form, but I also want a factored form. So what I like to do is come over here, give myself another little line. Obviously, the top's not going anywhere. How will we factor in the bottom? That looks like trinomial. What is going to multiply to make 20 and add together to make 9? What do you guys think? What's the pattern here? Is it 1 times 20, 2 times 10, 4 times 5? It's going to be 4 and 5, right? Piece of cake. So we're going to go ahead and add those up. X plus 4, x plus 5. And I promise you want to write these down on the notes. I promise you that. And now that we've factored them, we even want to go ahead and cross out what we can, okay? What is it that we can eliminate? We can eliminate the x plus 5. Okay, cool. Now, just to be very clear here, we still have a numerator, okay? The numerator is just a 1. And in the denominator, we have an x plus 4. Okay, so this is, these are both the same thing. These are both our graphs. Now, this one is simplified. This one is in the middle of being simplified, but this is all good. And now let's start knocking out our question here, okay? Just to prove a point here, if I go over here and I type 1 over x plus 4, the blue graph and the green graph are the same, right? I've simplified the green one. They're looking the same. They're feeling good. They're the same. So over here, let's start with our vertical asymptote. I always like to start here first. Our vertical asymptote. How do you find the vertical asymptote? Open up your little booklet. Vertical asymptote is bottom equals 0. Right. So really simply, we just need to take the bottom, set it equal to 0. That would be x plus 4 equals 0. And so what is our vertical asymptote? X equals -4. Is that the same thing it was for the last question? That is a bit of a coincidence, guys. That will not happen every time. That's funny. Well, it's not that funny. Lame math teacher, kind of funny, I guess. So -4, let's go ahead and slap an asymptote on there. Here we go. Horizontal asymptote up next. Horizontal asymptote, we need to compare the degrees. And so which one has a higher degree, the numerator or the denominator, the top or the bottom? The bottom, right? I'd agree. The degree of the top is 1. The degree of the bottom is 2. And so we have a higher degree in the bottom. And what happens if your bottom is bigger? Y equals 0, right? Okay. Well, let's throw an asymptote on there as well. Ooh, maybe I went a little wide with that one. And we're ready to just go ahead and throw our graph on there. You know, we know that we're going to be in the low side and then the high side. So I'll just go ahead and maybe grab a nice blue color. Just do the low side and the high side. Whatever. Good enough. Again, putting those curves on there does not need to be perfect. You do need to be near the asymptotes on your entrance and your exit. Okay, so it does have to kind of look like that. Now, this question, I'll tell you right now, is one of the hardest questions that you might see on a test or a quiz, right? So if this seems like maybe a little slow, but not too bad, then I mean, yeah, you're right. Let's go ahead and fill in some of these, right? We already found our vertical asymptote, which was, let me go ahead and get a better pen here. Our vertical asymptote, which was -4. Our horizontal asymptote, which was 0. Our X-intercept. Now, talking about X-intercepts, that was a go look on Desmos thing, right? So I'm on Desmos here. However, you know, my vertical asymptote is x equals -4, and my horizontal asymptote is y equals 0. I can turn both of those into red dashed lines just to make it look extra nice. Red dashed lines. If my asymptote is at 0, I cannot have an x-intercept, right? Because my asymptote is blocking off the entire x-axis, okay? If I scroll to the right, these two lines, they're never going to intersect. I don't ever see a gray dot along the x-axis. Sorry, here we go. And this one looks like it's along the x-axis, but that's actually my y-intercept. You can see here, right? That's actually my y-intercept. So there's no x-intercepts, even from -100 to +100. There's no x-intercepts. And so, yeah, this answer is none. And again, if you didn't have Desmos, how would you find x-intercepts? Top equal to 0, 1 equals 0. No, it doesn't, right? No, it doesn't. So you have no x-intercept. Okay, now we're almost done. We need to talk about the whole, the very last thing we're doing today. It is obviously the last thing that's going on here is the whole. And the whole is not on every question. Okay, the whole is, filling it in down here, something that was crossed out. Oh. The whole is something that was crossed out. Which obviously we didn't do any crossing out in that first question. but we did do crossing out in this question. And so that is why we actually do have a hole for this final question that we're doing here. Okay, we do have a hole, and we have a hole based on this stuff here, right? Based on this positive 5 that we crossed out. Okay, now, where would the hole be? The hole would be at -5. The hole would be at -5. So it's the same kind of idea, is you need to take the opposite sign of that 5. Now, what does that mean? If you think about it, in the denominator here, this in the denominator should have created a vertical asymptote, right? It should have created a vertical asymptote, but right before it created a vertical asymptote, it got canceled out. Okay, so it's kind of like you have this code red alert, and then at the last minute you solve the problem. Okay, and you cancel out that vertical asymptote. What that does is basically it's going to make it so that it looks very similar. Okay, and that -5, which would be right here, -5's right here. We're not going to have a second asymptote there, but actually what's going to happen is that when your graph is approaching that -5 value, okay, once it finally is going to touch that -5 value where there might have been an asymptote, it's actually going to just skip. And it's not going to do anything, okay? And so if we go back, that might be a little hard to understand, but I'll show you right here. If we go back, I told you guys, look, we've got a blue graph and a green graph. The green graph is the simplified version. The blue graph is the not simplified version. Now, the blue graph has the hole still included in it, right? And the green graph would not have a hole because the green graph doesn't have anything that's going to cancel out. But in the blue graph, we know the x plus 5s will cancel out. If I look at the green graph and I go to -5, you can see I get a nice little value there of -5, -1, right? Easy. If I go to the blue graph and I go to -5, a little tricky. There it is. -5, undefined, right? There's a little gap. It is literally only a -5, right? If I go to -5.01, it's there. If I go to -4.99, please, mouse, please, it's there. But right at -5, there's a little gap. And if you look at my cursor, you can see that we have that hollow dot there at -5. Okay, and that is how a hole is going to be demonstrated. That is how a hole is going to show up. Okay, so those holes are literally like a little tiny gap. It's maybe not the best drawing when I have this giant thick blue line as my graph, but if I erase this, it's going to look stupid. But if I erase this, and I'm going to do a nice little skinny graph, if my graph comes in like this, and then, it's so hard to do. Comes in like this and then leaves like this, okay? Right here at 5, when it's about to cross 5, I would just put a little open circle like that, just to denote that actually right there, I've done a little skip. Now, that's it for hole, but that's going to change one more thing, okay? Because if we've got that little skip, that will also be affected in our domain because we've skipped over that point there. Because not only do we not exist at the -4, technically we also don't exist at the -5. All right, that is it. I'm going to go ahead and fill in my domain and range here. My domain would be all real numbers. X cannot be the vertical asymptote, which is -4. X cannot be the hole, which is -5. The range would be all real numbers. Y cannot be 0, which is the horizontal asymptote, right? And maybe I'll even label these for you guys. we've got the vertical asymptote, the whole, and the horizontal asymptote. All right, that is it for the notes on how to solve these. What I'm going to do is I'm going to post another video, which is just me solving like 3 more questions like this, okay? And if you want to study for the test, if you want help with the homework or whatever, that is going to be hugely, hugely, hugely beneficial. This is easier than you think, okay? When you finish these notes, you think it's crazy. You think there's a million things to do. It is 6 easy steps, but that's, 6 little things you got to remember. Don't lose that study guide. I hope it helps. I guess I'll see you guys in the next video.